What happens if you remove every problem from living beings? Food is abundant. No predator threatens them. The space is safe and protected. Diseases no longer matter, except that they have to live together. If you still plan on sleeping tonight, by the way, I would recommend watching something else. Because one experiment created exactly such a perfect world. And in it, everything began to fall apart. A collapse that maybe also awaits us. Our cities are growing faster than ever before. In some metropolitan areas, more people live today than in the entire Roman Empire at its peak. In Tokyo, more than 37 million people are crammed into one metropolitan area. Mumbai grows so fast that every year another million inhabitants are added. And in Lagos, Nigeria, the population has quadrupled in the last 30 years. Housing is denser, trains more crowded, streets more congested. The more wealth we create, the more bodies are pressed into the smallest of spaces. But abundance sharpens the problem. Modern medicine saves lives that would have been lost before. More and more people survive diseases that once decimated whole societies. Advances in agriculture I'm sorry, my German accent here is acting up. I'm so sorry. Agriculture, I hope, make harvests possible that feed millions, even in times of drought. Drought? I hope I pronounced that correct. Industrial production ensures that hardly anyone has to live without clothing, tools, or protection. So every step forward removes one obstacle and allows even more growth. But growth is deceptive. What looks like a blessing in the early years turns into a new kind of burden in the long run. Populations explode, infrastructures reach their limits, coexistence becomes inevitably closer. Megacities transform into endless expanses of concrete, steel, and masses of people. The noise level rises, living spaces shrink, and fewer moments in life are free from the presence of others. This creates a paradox. The better we become at defeating suffering, the more another form of suffering comes to the forefront, the one that arises from proximity itself. But what happens when abundance reaches a point where closeness becomes the greatest danger? In the 50s, one topic moved into the focus of research: population growth. More and more people lived closer and closer together, and the questions arose. How long could this go well? While politicians discussed resources and economists worried about food shortages, a young researcher in the United States began to view this development differently. His name was John B. Calhoun. Calhoun was not a theorist who only made models. He wanted to see how overpopulation affected behavior, not in statistics, but in the action of actual living organisms. And his approach was quite radical. If you remove every external threat and eliminate every form of scarcity, then in miniature, you can see what happens to societies when nothing is missing. To do this, he designed enclosures that were as perfectly controlled as possible. Disease was excluded. Food and water were unlimited. Nesting sites were plentiful. Every detail was intended to prevent conflict over resources. Calhoun called those closed living spaces, universes. Artificial worlds where only one factor remained: the number of individuals coexisting side by side. For Calhoun, this was the chance to make the dream of a perfect life visible. A society without hunger, without hardship, without external threat. But even the early attempts showed something else, something different. Instead of a stable community, patterns emerged that revealed something deeply unsettling. The first experiments Calhoun conducted were in a smaller scale. At first, everything looked as one would expect under perfect conditions. The mice reproduced, groups formed, and the small societies seemed stable. But then patterns appeared that could not be explained by the conditions. Animals attacked each other, even though food and water were always available. Some mice withdrew their self completely, others neglected their young and let them die. For Calhoun, it was clear this was no accident. He wanted to make this dynamic visible on a larger scale. He moved his work to the National Institutes of Health and built an enclosure that is infamous to this day. It's called Universe 25. You could describe it as a kind of a mouse city, a square space about 2.5 meters wide with walls 1.4 meters high. The whole structure was strictly symmetrical, 16 sections, each with 4 vertical tunnels containing a total of 256 nesting boxes. On the walls, 16 feeding stations were distributed, each large enough to feed 25 mice simultaneously. Above them, water bottles, always accessible. The temperature was constant at an optimal level for mice. Disease was consistently excluded, nesting material regularly provided. The numbers show how far Calhoun went. In theory, the enclosure could have supported up to 9,500 mice. The water supply was enough for more than 6,000 animals, and even the nesting boxes could have accommodated almost 4,000. In other words, no shortage should ever arise. The only real limit was how many animals could coexist side by side. And in July 1968, the experiment began. 8 mice, 4 pairs of the bulb C strain, young and healthy, they were introduced. This was followed up by an acclimatization phase. Calhoun called this phase A. For 104 days, the small group fought over territories, spaces, and hierarchies. Behavior was marked by minor fights and social disputes until the first order was established. Then phase B began, which Calhoun described as exploitations of the conditions. In this phase, the population exploded. About every 55 days, the number of animals doubled. 20, then 40, then 80, then 160, then 320. Eventually more than 600 mice after just 300 days. The system seemed to do exactly what it was there for, what it was designed for. Unchecked growth under perfect conditions. But at this point, the dynamic changed. The doubling rate suddenly collapsed from 55 days to over 140 days. The population still grew, but much more slowly. Calhoun marked this as the beginning of phase C, the turning point at which the paradise began to tip. In phase B, stable structures had formed, the mice organized into breeding groups with hierarchy. These were small social communities around particularly desirable nesting sites. Each group was controlled by a territorial male, a male that claimed a territory and kept others away with aggression. This system initially maximized the use of resources. The mice continued to reproduce, and the population grew rapidly. But by the end of phase B, the good territory was exhausted. About 14 established groups with around 150 adult animals occupied the best places. Opposite them were almost 500 younger, unestablished animals that found no social role. In a natural habitat, they would have migrated, but Universe 25 was a closed system. They became outsiders without a place within a closed system. And this was where the break began. With the transition to phase C, behavior changed dramatically. The outsiders withdrew. They physically withdrew and mentally. Many males gave up trying to conquer territories or defend females. Instead, they gathered passively in groups at the bottom of the enclosure, moved less and less, and showed odd reactions, sudden, aimless attacks on random individuals. Also, females that found no place in the central nests moved into the upper ones, less attractive nesting boxes. But even the established males lost strength. Their ability to defend nests collapsed. They had fatal consequences. Intruders invaded nests. Their children were injured or killed. Mothers reacted with extreme aggressions, often not just against intruders, but also against their own offspring. The result was a comprehensive collapse of reproduction. Births declined sharply. Many females aborted pregnancies or abandoned their young. Also, something else was happening. In technical terms, this is called fetal resorption. The body dissolves an embryo in the womb before it fully develops. Other litters ended with injuries, neglect, or deliberate killing of the young. This collapse of maternal care marked the point at which population growth came to a standstill, even though food and space were still available. Despite all this disruption, Universe 25 reached one more peak, about 2,200 animals around day 560. In theory, the system could have supported almost twice as many, but around 20% of the nestling sites remained unused even then. The resources were plenty, but the social structure no longer allowed them to be used effectively. Then phase D began, the final phase. The population shrank and never recovered. The last births were recorded around day 600. After that, the population simply aged. There were no more young, no renewal of the community. What remained was an overcrowded, aging society whose members slowly disappeared because the social fabric had collapsed. With the social collapse, behavior changed as well. Some males developed a pattern that Calhoun later called the beautiful ones. Those animals withdrew completely from all social contact. They no longer fought for territories. They no longer tried to reach females. They did not defend their younglings. Instead, their behavior was reduced to basic functions, eating, drinking, and sleeping, and endlessly grooming their own fur. They were flawless, without scars or bite marks, outwardly healthy and shiny. But behind this facade was a total loss of social function. The females also showed a dramatic change. In autopsies of a parallel population, Calhoun found 82% of females had never carried young. Only 2% were pregnant at all, and not with normal litters of 5 to 8 young, but with single embryos. Reproduction had almost completely ceased. Perhaps the hardest insight came from a rescue attempt. Calhoun took a small group of mice that had survived the collapse of Universe 25 and placed them in a new enclosure. There, the same perfect condition existed as at the start: fresh food, clean water, safe nesting spaces, but it changed nothing. The animals did not resume their old patterns. There was no return to reproduction, no stable social structures, and no functioning communities. What had been lost remained lost. Calhoun called this the first death, the death of behavior long before the body dies. A living being that still exists, physiologically at least, but not ceased to fulfill the functions of its species. The final picture is also hard to gloss over. Resources at abundance, technical limits far away, and yet a population dies out. But Universe 25 was a laboratory. And here begins the real question that still stands today. Was it only an artifact, an extreme scenario for mice? Or did Calhoun reveal a dynamic that also applies to us? The observations from Universe 25 did not go unnoticed. They were quickly linked with development in human societies, in big cities. Millions crowd into tight spaces. In New York, almost half of the population lives in apartments with fewer than 3 rooms. In Tokyo, the average commute takes more than an hour and a half each day, packed into trains filled to the limit. In Mexico City, the metropolitan region grows by hundreds of thousands each year, while infrastructure struggles to keep up. At the same time, standards of supply rise. Supermarkets fill their shelves with goods from all the continents. Medical care extends life expectancy by decades, and digital technologies connect billions in real time. But the more those systems achieve, the closer humans are pressed together in apartments, in transport networks, in labor markets, in social media. Proximity becomes the constant. Paradoxically, so does isolation. Thus arises the impression that the pattern of Universe 25 is not just a biological footnote. I'm sorry again for my pronunciation. It describes a dynamic that can also be seen in modern societies. But are these parallels more than just a metaphor? Well, here the scientific debate begins. Supporters see Universe 25 as a warning. They argue that overpopulation and density inevitably lead to social tensions, whether in mice or humans. The denser the community, the stronger the burden of proximity, noise, and competition for status. Critics, however, point to the differences. Mice are territorial animals with fixed instincts. Humans, by contrast, have culture, institutions, and flexible behaviors. Migration, family planning, technological innovation. All this creates options that mice in a closed system lack. Still, Universe 25, they argue, is an extreme laboratory artifact, not a model for human society. Still, the impact remained. The study was cited in newspapers, books, and political debates. Terms like behavioral sink appeared in analysis of crime and inner cities of declining birth rates in industrial nations. Even those who dismissed the results as a distorted image could not escape it. The image of a mouse city collapsing in abundance burned itself into collective thought. In the end, it is no longer about what happened in Calhoun experiment. The processes are documented: growth, stabilization, collapse, extinction. What matters is how we understand them. When resources are no longer the problem, when technologies eliminate more and more scarcity, what happens to societies forced to live in ever greater densities? Universe 25 was a, laboratory experiment, but the question it arises reaches far beyond. Was it a special case, a distorted image of a biological extreme, or a mirror showing us where abundance and density could lead human communities as well? The answer, well, I leave the answer to you. But for now, thank you for watching. I really hope you enjoyed that episode, and leave me a sub. That would be nice if you're looking for more episodes like this.